help us understand, Professor He, of the latest development of your field, the DNA and especially RNA. Why are they important and significant for us?
Right, yeah, I think when you talk about life science or medicine, right, if you go really to the mechanistic part, you have to think about central dogma. You know, what central dogma is basically the genetic information we carry over from our parents encoded in DNA that flows to RNA and eventually to protein, right? And this is how the life is made of, right? All the biological functions performed, right? So the control of this genetic information flow is incredibly important for, say, development, for diseases, progression, et cetera, et cetera. So for decades, right, people know if you have modifications or chemical modifications on DNA and proteins play incredible, important functions to control what we call gene expression regulation. It basically means to regulate the genetic information flow from your encoded DNA into a biological function, right? So what we've been working on, or from my lab, we found, in fact, there's another way life actually has put on a control of this gene expression regulation through dynamic, reversible chemical modifications on RNA. And so we're very excited. It's a new field of biology. Probably will have implications in many areas.
Many have said, you know, for physics, it's really about understanding our relations with the rest of the universe. But for chemistry, the field that you are working in,
right,
or biology, it is more about understanding ourselves. Sometimes it could be even more difficult.
Well, definitely, because that's a philosophical question, right?
It
How
is.
are we going to understand ourselves,
Yes.
right? In particular, brain, right? What's amazed me most is if you think about ourselves, we have trillions of cells, and all those come from one single fertilized egg, right? Embryo. Now, during that differentiation development, one cell encodes all the information for everything we have in our body, right? So that's something amazing, right? Now, that's something I've been fascinated, right? Another thing, of course, everybody's been fascinated by brain function, right? That goes back to your question, the philosophical question, how our brain could understand our own brain.
When it comes to disease,
Right.
of course, which is one of the areas your research is typically extremely important, we seem to have a lot of knowledge about your field, biology or chemistry. But when it comes to real solutions to diseases that we're having these days,
Right.
let's just say cancer,
Right.
we seem to be very incapable of transforming what we already know into something extremely useful for the common folks.
Not exactly.
Okay, go ahead, explain to me.
Well, since you mentioned cancer, right? In fact, if you look at the U.S., the cancer, the death rate has been dropping, right? We've made a huge amount of progress. We're not making something like, overnight we cure cancer. There's no way, because there's a general sort of misunderstanding of cancer. It's multiple diseases. We have to focus on each one of them. There are hundreds, thousands of different diseases. We call it cancer, right? Whenever we solve a disease, there's another disease come up, right? Yeah. So this is a continuous effort, right? But in the last 20 years, we made a huge amount of progresses. Like prostate cancer, the death rate is very low. Testicular cancer used to kill 90% of.
But there are many other
males.
varieties of cancer. We still do not have any solution.
True. So that's why that's why I still have a job, I guess.
That's true. I'm sure you have a long way to go.
But well, sure, yeah. There are still challenges ahead of us. Actually, just like you said, we're trying to understand ourselves. Cancer is part of ourselves.
What do you think could be some of the most exciting development in that field, do you think, that we should know?
I think precision medicine becomes sort of very popular these days. However, the concept, the idea is fantastic because, as I said, cancer is a very it's very heterogeneous in a way, right? It's sort of a multiple diseases, and based on your different individuals, it could be different, right? But we still need to gain a lot of knowledge on different subtypes of cancer. What causes this cancer? We actually don't know. If you go to medicine, you'll be shocked how the doctors treat you. They don't really have a guidance in lots of cases. The ones, particularly the ones you mentioned, right? The ones we actually can cure are the diseases, the cancers we can actually know what causes this kind of cancer. Then we can target them, right? So this is why we require basic research. So, for instance, figure out the genetic causes or the environmental causes of certain particular cancer. What mutation, what physiological status leads to this cancer. Then we have a target we can intervene with either therapies or other means.
Right. What do you make? It seems that what you are doing, Professor He, are really basic research. What is the role of basic research these days, do you think? When you see entrepreneurs popping up all around you, become millionaires, not sometimes even billionaires, what do you make of this reality?
Well, I think there are two sort of aspects of this, right? The reason we choose science is because we have this curiosity, right? We want to understand the unknowns, right? We want to provide a new knowledge for us, and first for us, and then for the society, of course, right? Second, I think there's a misunderstanding of the basic research, right? There are different levels of basic research, but if you pick an important problem and make an impact, right? Typically, a breakthrough in basic research generates new industry, generates new business, right? It's not sort of an incremental type of advance. Instead, it's a quantum leap, right? Most of the sort of the revolution in industry or business comes from breakthroughs in basic research, in particular in life science. Right? So, myself was also interested in entrepreneurship. We have breakthroughs in our research, and we're advancing those into therapy or clinical applications.
Are we going to be directed our attention from real basic research because we are trying to make it marketable in a way? As a result of the basic research?
I think when you pursue a basic research, you really did not see the potential of application, right? It's a very basic research, but as I said, if you pick an important question, in particular in biology, I'm not sure about the physics or math, right? But there probably others can comment. In life science, if you really discover a new pathway or discover the new mechanism, that typically leads to new therapies and new ways to treat disease or new ways to somehow benefit the society. If you look at the history, it has always been the case, right? So I think the key is you love your work, find it interesting, and be innovative, and the rest will come by itself.
So as a scientist, I would assume that you would feel the fun while trying to approach all of these subjects, all of these challenges. But I would also assume that you would have the pressure because it is really up to you guys, of course, not just yourself, but many others as well, in the field that can really make a difference to our lives and the qualities of our lives.
I guess most of us have not thought about that, or just enjoy what we're doing.
Interesting.
Right. Well, science is very competitive. I actually like one of the Future Prize committee members, Professor Xiaodong Wang. He actually described scientists as someone hanging on the cliff or always hanging there because it's a very competitive field. If you don't advance your knowledge, your research, then you're out of the fashion.
Well, but that's a lot of work, isn't it? You really have to get to know at least the basic principles of other fields in your interdisciplinary studies or research.
Right. Well, that comes back to as a scientist, I always thought, as a good scientist, you have to keep reinventing yourself, right? So you have to learn new things. Otherwise, you can't be innovative.
Professor He Chuan was born in Guizhou, one of China's least developed province which lies in the southwest. He graduated from the University of Science and Technology of China with a bachelor degree in chemistry. After his PhD training at the Massachusetts Institute of Technology, He worked as a postdoctoral fellow at Harvard University. Then he started his independent career in the Department of Chemistry at the University of Chicago. It took him only 2 years to get promoted from associate professor to professor, breaking the record at the University of Chicago.
Professor He, you started in Guizhou province.
Right, I was born
as
there.
a child. And that was one of those areas the least developed in China at the
That's
time.
true.
There seems to be a disconnect of the environment you were born with where you are today as a scientist.
Yeah, well, I was actually born in the mountains. I attended the elementary school in Guizhou. It's kind of fun, almost like my daughters in US because deep in mountains we don't really have that much. What's the best way to put this, right? You're basically free to explore whatever you like, right?
Both of your parents are chemists,
My mom is a chemist. My dad is a doctor.
and they were sent to Guizhou province to what you call develop the latest technologies for China's national security or something like that.
Right, I think in 60s, 70s in particular, right, the time where when the Chinese fear there will be potential war, and they moved a lot of their defense industry and universities, for instance, University of Science Technology out of Beijing, and defense industries out of major countries, and move them into mountains, rural areas like Guizhou or other places, right? And then they build small factories. These factories, so instead of a big factory, sort of divide those into 10, 20. Each was separated by something like 50 miles. So the whole idea is this has become individual units that can function, right? So that's where, and then of course a lot of graduates from college were sent there to serve the country. So my parents were among them, right? I'm not sure it was a good experience for them, but it was a fantastic experience for kids like us because we get to grow up in mountains. It was just so much fun. We never really started for many years.
At least free-spirited.
It's free spirit. I always say it's a free spirit. I think that might be important.
What about the level of research in your field in China compared to where you are now in the US?
I think in the last 10 years, we've seen almost like a quantum leap, right? We've seen major advance of scientific research in chemistry, life science, physics, right? For instance, we're setting up this prize, all right, to award those. It's getting closer, right? But there's still gaps. In certain areas, the gap is pretty wide, but in other areas, China may start to lead. Right?
When it comes to life science, it is always related to ethical issues.
Right.
And also related to different kinds of political issues as a result of the discussion of ethical issues.
Sure.
You in the United States, you understand this certainly with embryo, for example,
Right.
and in China there are different cases. As a scientist, what do you think about this?
As a biologist, well, I'm a chemist as well, right? So, there's this history. The chemists made all the chemical weapons, right? The physicists made all the atomic bombs, right? And the biologist makes probably all the, the weapons, whatever. I think
Are scientists guilty?
the scientists are not guilty. The scientists are not, they're pursuing, they're trying to satisfy their curiosity. Right? Whatever their inventions, discoveries being used, right? Just like a gun, right? You can defend yourself, but you can also, harm others. Science is the same way, right? I think as a scientist, you want to explore the new territories of the knowledge, right? At the same time, I think most scientists have their own sort of standard, moral standard, right? You don't want to make a genetic mutated organisms to harm the ecosystem. So, but however, I do believe the government and whatever the community needs to put in relevant rules to prevent certain scientists to perhaps step out of the boundary.
Does science have national boundaries?
We hope it doesn't have the national boundaries, right? The reality is there are some, the different culture, there's the different education research systems, right? People do science slightly differently. The intellectual environments are different, but the knowledge, right, is common.
Since we're talking about future, you're also on the judging panel for this Future Science Award. Of course, it's a very unique award.
Right.
As a scientist yourself, what do you think are the most important qualities of a scientist today, and particularly for the future?
Well, I think as a qualified scientist, they have to be driven by curiosity and persistent, but most importantly, you have to be innovative. Right? I think for future prize, right, it has to be something innovative, right, leads the world, and hopefully, not all, make a major social impact.
Where does that innovative spirit come from?
That innovative spirit comes from training, but also intellectual environment.
Such a pleasure, Professor He, to have you with us.
Thank
We
you.
learned a lot. Thank you.
Very
Really
much.
appreciate it.
Thanks.